Hey everybody! Today we're going to look at some of the cool things we can do with the curve spiral node. We're going to start by looking at all of the available inputs and demonstrate how the shape will change as these values are adjusted. Then we'll see how to bring in multiple spirals and animate them. We'll take a look at how we can add some noise to our geometry to distort its appearance. And we'll also look at the resample curve and trim curve nodes and how these can be used in animation. Next, we'll explore using an instance on points node and bring it all together with animating the instances on points. I'm going to open a Geometry Nodes editor in the default layout workspace, but feel free to use the Geometry Nodes workspace if you prefer. And I'll close the sidebar menu with the N key. Now let's add a new Geometry Nodes modifier to our default cube. We can delete the Group Input node, and then we're going to add a Curve Spiral node with Shift-A to bring up the Add menu, and then select Curves, Primitives, Curve Spiral. We can now see the default spiral in our 3D viewport. If we click on the spiral, it will be outlined in orange and easier to see. We're going to add a curve to points so we can look at the resolution property better. We'll also open a viewer by using Ctrl-Shift left mouse click and selecting the node we want to connect to the viewer. In this case, our curve to points node. Let's change our curve to points node to evaluated. Now we can see that we have 1 point for each point in the spiral. The resolution is the amount of points in one single rotation of the spiral. So with 2 rotations, we have 64 points, with a resolution of 32. As we move our resolution up and down, we can see the amount of points in our spiral increase and decrease. Now we can get rid of the curve to points node and the viewer. Next, we'll take a look at rotations. This is the number of complete 360-degree turns in the spiral. We can also use decimals to add partial rotations. And you can see that the number of rotations correlates to the number of rotations here, along with our decimal portion here. Let's take a look at the side view. And we'll adjust our rotations some more to see how this looks from the side. Next, we're going to look at the start radius. It's important to remember that the start of the spiral is at the bottom, so this will affect the bottom part of our spiral. Now let's adjust the end radius, which naturally will be at the topmost part of our spiral. Let's take a look at the height, which will control the height of our spiral. As we make it taller, it will retain the same number of rotations. They will just be more spread out. Let's also take a look at the reverse checkbox. This will reverse the direction of the spiral. This will make our spiral's direction counterclockwise, starting from the bottom, or the start. By default, the spiral will turn clockwise from the starting point. Let's go ahead and add a curve to mesh node so that we can see and render our spiral. We'll also need a curved circle for our profile curve. Let's reduce the radius of our curved circle so that our spiral is more readable. You can use the Shift key for finer control of this adjustment. I've set mine to 0.1. Let's add a transform geometry and see how we can animate our spiral as a spring. We'll shorten our timeline to 100 frames. Let's move to frame 0 and then keyframe the scale. We'll move to the end and keyframe the scale again, still at 1 or full scale. Now we'll move to frame 50 in the middle of our animation, and we'll set the Z-axis scale to 0.3 and keyframe that as well. Now let's take a look at our animation. Let's return to frame 0 and clear the keyframes on our transform geometry by right-clicking and selecting Clear Keyframes. Now we're going to add a Join Geometry node so that we can make a few copies of our spiral. We're going to take our Curve to Mesh node through a Transform Geometry node and set the Z rotation to 90. Then we'll connect this to our Join Geometry node. Let's duplicate this transform with Shift-D for the next copy. We'll collapse the first transform geometry to save some real estate on the screen. Next, we'll update the rotation to 180 and then hook this node up from our Curve to Mesh node and to the Join Geometry node. Let's duplicate this once more, collapse our previous transform, and update the Z-axis rotation to 270. We'll hook this up just like the previous ones, and now we have 4 spirals, evenly spaced apart. Let's scale the rotation down. This will affect all 4 curves concurrently. We'll scale these back up to give us more geometry, and let's also adjust the height to give our spirals some breathing room. Let's animate our 4 spirals. We can keyframe the 0 rotation at frame 0 and then move to the end, where we'll keyframe our Z rotation at 360 degrees. Now let's watch our simple animation. Next, let's set our ending keyframe to -360. And notice, as expected, that our rotation goes in the opposite direction. Next, we'll add in a Trim Curve node between our Spiral node and the Convert to Mesh node. Notice that we have 2 options at the top, Factor and Length. We'll look briefly at both. First, on Factor, let's adjust the endpoint of the curve, and we can see our spiral shrink as we move the value down. This is essentially a fraction of the whole of our spiral, and as we move the value down, the end of our spiral is trimmed accordingly. If we move the start value up, this will trim the spiral from the start. Now let's take a look at length. This will measure the spiral in meters. With the default 1 meter, we will get 1 meter of our spiral. We can adjust this up, but if we go past the length of our spiral will not increase past its original length. We can also adjust the start of our spiral up the curve by the length indicated. We're going to go back to Factor and animate the trim to see how that looks. Let's go back to frame 0 and keyframe our value of 1 here. We'll move to the last frame and keyframe the 1 value there as well. Next, let's jump to frame 50 and keyframe a lower value, say 0.5. Let's take a look at how our animation looks now. Next, let's take a look at distorting our spiral. Right before the last transform geometry node, we are going to put a set position node, available under Geometry, Right, Set Position. We're going to add a noise texture from the offset of our set position. This can be found on the Add menu under Texture, Noise Texture. We can see that this has distorted every point on every axis. Let's also set our noise texture to 4D so that we can animate it. We can limit this effect to only 1 or 2 axes though. Let's add a separate geometry and a combine geometry. And then we can bring over only the axes we want to offset. In this case, the X and Y axes. We can see that the offset has moved the mesh away from the center. If we animate it like that, we will get some unintended results. So let's add a transform geometry node just before our set position and move our spirals so that they are centered once more. We can go ahead and collapse this node. For now, we're going to disable the trim curve by bypassing it. We'll place it out of the way here because we will come back to it. Let's go ahead and animate our noise texture. We'll move back to 0 and keyframe the W at 0. Now we'll move to our last frame and keyframe the W at 1. Now we can see our distortion move along the X and Y axes. However, we can see that our animation is not a smooth loop and has a slight glitch as it moves from the last frame to the first frame. Let's fix this. We'll add a mix color node between the noise texture and the separate XYZ. We'll make sure we are using the color element of the noise texture. Let's return to frame 0 and then duplicate our noise texture. we'll bring this noise texture into the B color for the mix node. We'll set the W of the noise to 1 and keyframe that. Then we'll need to move our mix value up to 1 and keyframe that as well. Now let's go to our final frame. We'll bring the mix value down to 0 and keyframe. Then we'll set our second noise texture to 0 and keyframe that as well. Now when we play our animation, we can see that the glitching is gone and it loops perfectly. Let's move back to our 0 frame. Now we can remove our noise texture and mix node. Also, the set position and the separate and combine XYZ nodes. And since we removed the distortion, we no longer need this transform geometry because it will be perfectly centered without it. Let's also go ahead and remove our curve to mesh and curve circle nodes as we prepare to look at creating instances along our spiral. We'll place an instance on points node directly after our join geometry node so that we can use all of the points in all 4 spirals. Let's add an icosphere as our instance object. We'll bump the subdivisions to 3 and we'll scale the radius down to 0.13. Using our existing spinning animation from the transform geometry node, we can see that all of our instances spin in unison. Let's see if we can make our animation more interesting. We'll add a resample curve node at our original spiral so that it will be used for all of the copies as well. This defaults to using count and a count value of 10. Basically, this will take the whole of our spiral and replace all the points with 10 points instead. These will be evenly distributed along the curve. We can see how this changes our instances as we scale this up and down. We can also use length. This is currently set to 0.1 meter, so we will have an instance every 1/10 of a meter along our spiral. We can scale this up and down to affect how many instances are present in our spiral. For now, let's go back to count, and let's animate this property. We're going to set the count back to 10 and keyframe this at frame 0. We'll move to the last frame and keyframe the 10 value there as well. Now let's go to frame 50 and keyframe the count at 55. As we watch our animation play, we can see some really cool patterns emerging in our 3D viewport. Now let's add our trim curve node back in with its existing animation. Because we are trimming it before we are resampling it, we are getting all of the resample counts on our spiral, regardless of the length after the trim. So what happens if we move the trim after the resample? Let's take a look at that now. The reason we are seeing these kind of floating icospheres is because we are setting our count first, then progressively trimming and untrimming our spiral. So the last point in the spiral is receiving an instance where there is a partial curve section left. And when these were reversed and the trim happened first, then the number of points was evenly distributed across the length of the spiral. You can see the effect more if we slowly scrub through our timeline. That's going to conclude our discussion of the curved spiral node. I hope you have enjoyed this content and found it useful. If you have any questions or comments, please be sure to leave them below. Please like and subscribe to help support this channel so I can bring you more Blender content. I look forward to seeing you in the next video, and I wish you a very happy blendering.